Hello, everyone, and welcome. I'm Aditya Deshmukh. In this session, we'll walk through how we can significantly improve product search across a multi vendor procurement experience. We'll start by looking at the core pain points that buyers and agents face today, especially when product data is inconsistent and fragmented across suppliers. Then we'll introduce a solution approach that combines better data ingestion, unified taxonomy, and AI powered search. Finally, we'll show a demo of what this improved experience looks like in practice. Let's start with the key challenges in multi vendor procurement platforms today. First is data fragmentation. Every supplier tends to describe the same product differently, like white pencil versus pencil in white color. This creates taxonomy chaos and prevents a unified product representation. Second, we see search inefficiency. Front end users struggle because search depends heavily on exact wording. Small variations lead to irrelevant results, or worse, zero results. Third is workflow bottlenecks. Agents spend more time hunting for the correct SKU instead of completing purchases. Over time, this slows down procurement operations. Fourth is a lack of revenue attribution. If the platform doesn't have clean product level metadata, it becomes hard to tie revenue back to specific products or categories, which limits reporting and strategic decision making. Fifth is contract compliance risk. Buyers can't easily distinguish between contracted items and off contract alternatives, which increases spend leakage. Sixth is portal fatigue. When the experience forces users to jump between multiple supplier interfaces, it becomes frustrating and inefficient. And finally, inventory blindness can occur when stock updates are inconsistent, leading to cancellations and loss of trust. So, overall, poor product data plus weak search creates operational friction, compliance risk, and lower conversion. This slide summarizes the root problem and the solution approach. On the left, we see what's happening today. Product data is coming in from multiple vendors in inconsistent formats, creating confusion and ineffective search results. To fix this, we apply a three-step enrichment process. Step 1 is normalize and tag. We standardize incoming product attributes and apply consistent tagging across vendor sources. Step 2 is classify and code. We map products into a unified taxonomy, such as categories, and apply standardized classification codes like UNSPSC. Step 3 is enrich with metadata. This is where we add synonyms, usage context, and searchable terms so the platform understands what users mean, even if they don't type the exact words. The result is a clean, structured, enriched dataset powering search excellence, where users can find what they need quickly and accurately. Now, let's talk about how we operationalize the process of building and maintaining high quality product data. Because the key isn't just initial cleanup, it's long term sustainability. We propose a modern data explorer with a human in the loop curation workflow aimed at achieving high precision and creating reliable master golden records. First is auto category mapping. The system suggests taxonomy mappings, and agents review and correct them. This allows us to scale while still maintaining accuracy. It includes approval, escalation, and audit trails. Second is KPI ranking. Since teams can't work on everything at once, we prioritize SKUs using engagement signals like demand, conversion, and search frequency, so the team focuses where it matters most. Third is real time alerts. During daily vendor sync ingestion, the system flags missing attributes, duplicates, or conflicting data before the data pollutes the golden record. And fourth is fluid navigation. Agents can quickly explore taxonomy, drill into issues, and reduce zero result queries using diagnostics and suggestions. The operational targets are clear: 95% precision, faster time to resolve, fewer zero result searches, and higher coverage. This slide shows how the transformation evolves from the current status quo to the target AI powered state. Today, users often struggle with exact keyword matching, which leads to poor relevancy and frequent zero results. The target state is a hybrid approach, semantic plus neural search, that understands user intent and language variations. Right now, product catalogs are chaotic due to inconsistent naming and duplicates. In the target state, we establish a unified golden record for every product, standardizing taxonomy across suppliers. Contract compliance today is largely manual. Agents must verify whether an item is on contract. The target state uses automated policy engines and customized catalogs to ensure results are contract compliant. Sourcing today is resource heavy, manual RFPs, and switching between supplier portals. In the target state, procurement becomes streamlined, saving up to 500 sourcing hours per category. And finally, leadership today has limited metadata, so it's hard to link spend and revenue to categories. The target state delivers spend visibility and predictive analytics for better ROI decisions. Overall, the buyer journey shifts from fragmented and tiring to frictionless and Amazon like. Now, let's look at the technical architecture, how we enable unified ingestion, modern search, and grounded AI generation. The architecture is organized into four zones. First is the ingestion and standardization zone, also called the clean room. Vendor feeds come in through APIs or batch ingestion. Here we run deterministic normalization, entity resolution, and golden record building, storing everything in a versioned data lake like Delta Lake or Iceberg. Next is the indexing and storage zone, the search engine. We generate embeddings using semantic models and build a consolidated hybrid index in OpenSearch. This includes lexical keyword fields, dense vectors, and sparse vectors, so we get both precision and semantic understanding. Then comes the serving and intelligence zone, the orchestrator. A user query enters through the UI or API, passes through a policy engine, RBAC or ABAC, to apply entitlement filters. Then we run hybrid retrieval, apply reciprocal rank fusion ranking, and finally a gated re-ranker using a cross-encoder for high accuracy. Finally, the generation and grounding zone, the reasoning engine. Here we distill the most relevant context, prompt the LLM, and most importantly, run grounding checks and citation mapping, so every generated answer is traceable to a source record in the data lake. The outcome is a secure, high relevancy search experience with grounded AI answers and an audit trail. This slide explains two key things: how we validate the architecture and what each component does. From a testing standpoint, we apply a structured feasibility gate across each zone. For indexing, we validate a unified OpenSearch strategy and run accuracy testing using human-in-the-loop audits to ensure over 95% precision for golden records. For normalization, we test deterministic rules for predictable performance and confirm the index can handle sub-second retrieval. For security, we validate that the policy engine filters data before it touches the index or the LLM. For retrieval, we benchmark hybrid retrieval plus RRF and re-ranking against a ground truth query set. And for grounding, we red team the LLM to reduce hallucinations and ensure strong citation mapping. Now, in terms of components, deterministic normalization standardizes raw attributes. Splink Entity Resolution identifies duplicates. Delta Lake becomes the versioned single source of truth. OpenSearch stores lexical, dense, and sparse vectors. The policy engine enforces entitlement. RRF and re-ranking improve accuracy. And the LLM generates responses, but only after grounded context is prepared and validated. So, this is not just an AI system, it's an enterprise grade system with governance, testing, and auditability. This slide outlines a 6-month delivery plan structured by work streams and major milestones with validation gates at each stage. In months 1 to 2, we focus on ingestion, integrating the top 3 vendor feeds, implementing initial normalization rules, and setting up Splink entity resolution. We validate success through accuracy testing, targeting over 95% precision for golden records. In month 3, we implement indexing, a unified OpenSearch setup, a single embedding model, and daily batch sync, along with performance testing for sub-second retrieval. Months 4 to 5 focus on serving, building an MVP policy engine with RBAC, fixed RRF weights, and a lightweight gated re-ranker. We validate relevancy by benchmarking against a ground truth query set. In month 5, we perform integration, system integration testing, and UI UX finalization, validating that entitlement filtering works end to end. In month 6, we enable generation, refine the natural language interface, finalize prompts, set up citation mapping, and implement user feedback workflows. We validate grounding through red teaming. The final goal at the end of month 6 is UAT rollout and ROI calculation, so we can present an executive report backed by real results. Now let's look at the demo capabilities. Feature 1 is keyword search combined with AI-assisted semantic search. In a traditional system, searching for something like draw might not return items like drawer because the keyword doesn't match. But with fuzzy semantic search, the system understands that users may be referring to related concepts and can intelligently return relevant products. In the UI, users can toggle between standard keyword search and AI-based search. Results remain vendor filtered and they are ranked by relevance. So the benefit is fewer zero result searches and faster discovery, especially when users don't know the exact product name or vendor naming convention. Feature 2 is image search. Instead of typing a description, users can simply upload an image, like a photo of an office supply item, and the system will search across vendor catalogs to find similar products. This is especially useful when the user doesn't know what the item is called or when different vendors use different naming conventions. In the interface, the user uploads the image, the AI interprets what the item is, and the system returns relevant products, again across multiple suppliers, ranked by relevance. This helps reduce friction and improves purchasing speed, especially for repeat needs or visual identification tasks. Feature 3 builds on image intelligence. The system can extract product features directly from images and enrich the product listing. For example, when viewing an item like a vertical file cabinet, the system can identify key attributes like number of drawers, color, dimensions, and other specifications, and display them in a structured way. This is powerful for 2 reasons. First, it improves the buyer experience by making product details easier to compare. Second, it strengthens the platform's metadata, feeding back into better ranking, filtering, and taxonomy tagging. So instead of relying only on vendor-provided descriptions, we use AI to enrich the catalog and improve search and discovery. This slide shows how AI supports taxonomy and product intelligence at scale. On the left, we see a taxonomy hierarchy. Categories like office basics, office supplies, and subgroups like clips, fasteners, binders, and tape. This hierarchy helps users browse naturally, not just search. On the right, the system automatically performs several tasks: auto taxonomy tagging, mapping products to the correct category; auto discovery of topics, identifying what the product is commonly associated with; improving descriptions using AI by infusing synonyms and keywords so search becomes more forgiving and effective; and finally, ranking by popularity using engagement signals so the most useful items surface first. This is how we move from a messy, vendor driven catalog to a curated, intelligent catalog that supports both search and discovery. This slide summarizes the 180-day plan as 5 iterative phases. Iteration 1 focuses on foundation, analyzing current data, mapping the target architecture, cleaning taxonomies, defining unified schemas, and running Splink entity resolution to identify duplicates. Iteration 2 moves into search readiness, deploying semantic models, building hybrid indices, configuring OpenSearch for lexical and vector search, setting up daily batch sync, and ensuring sub-second retrieval through performance testing. Iteration 3 focuses on the intelligence layer, building the natural language query interface, setting up RBAC policies and dynamic filters, and optimizing ranking through RRF and re-ranker tuning, benchmarked against ground truth queries. Iteration 4 is integration, finalizing UI features, performing system integration testing across zones, validating policy security, and confirming end-to-end system performance. Iteration 5 is about trust and rollout, refining system prompts, mapping citations, incorporating user feedback, red teaming for hallucinations, presenting an executive demo, calculating ROI, and completing pilot rollout and validation. So by the end of 180 days, we don't just have a prototype, we have a tested, governed, and measurable solution ready for production rollout. This Gantt chart visualizes the same 6-month roadmap across 5 zones: ingestion, indexing, serving, integration, and generation. In months 1 and 2, ingestion delivers top vendor feeds, normalization rules, and entity resolution. Month 3 completes indexing with unified OpenSearch and embedding strategy. Months 4 and 5 deliver serving capabilities like policy engine, RRF weights, and re-ranking. Integration testing happens around month 5, and month 6 completes generation with natural language interface refinement, citation mapping, and feedback loops. At the end, the final POV goal is rollout, supported by testing gates across accuracy, performance, relevancy, integration, grounding, and final UAT with ROI validation. The key takeaway is that every phase has measurable outcomes and validation gates, so progress is controlled and results are provable. Thank you for your time. That concludes the overview of our approach to improving product search using unified taxonomy, hybrid semantic retrieval, and grounded AI generation. We'd be happy to walk through the demo, discuss next steps, and align on the best path forward for a pilot.